Very good evening, students. Today we are going to see the subtopic of Unit 2, parametric and non-parametric statistical test for hypothesis testing and confidence intervals. Hypothesis testing and confidence intervals are essential in chemical engineering for process control, quality assurance, and experimental analysis. These statistical methods help engineers make decisions based on sample data, ensuring that conclusions are reliable and applicable to real world scenarios. So, first and foremost, we should know the differences between what is parametric test and what is non-parametric test. So, these both are coming under the statistical test. Okay. Statistical tests are classified into two categories based on the assumptions they make about data distribution. So, let us say the parametric test, the assumption is made is normal distribution, whereas in non-parametric test there is no assumption. Do not assume a specific distribution and useful for non-normally distributed data. Now, the question is, what do you mean by non-normally distributed data? Like Gaussian distribution, which is characterized by a bell-shaped curve, this is not actually does not fit for the non-normally distributed data. So, non-normally distributed data refers to data that does not follow a normal distribution. So, such data may be skewed, have heavy tails, or contain outliers. Outliers is a deviation from the mean. Okay. So, it is a vast deviation. So, the characteristic of non-normal data, it may be a skewed distribution or heavy tails, bimodal or multimodal distribution, or presence of outliers. What is skew distribution? The data is not normally symmetrically distributed, heavy tails, more extreme values than a normal distribution, bimodal or multimodal distribution, multiple peaks in the data, presence of outliers, large deviation from the mean. So, first and foremost, I can give an example for Gaussian distribution. The bell shaped curve is your, let us say, imagine a class having writing the exam and I have the final exam marks. This usually we will look into a normal bell shaped curve distribution, meaning to say the failure as well as the topmost will have been skewed at both the end, and we will supposed to get a bell curve. So, it is a normal Gaussian distribution. Most of the time, almost I can say almost 99% of when the exam has been conducted fairly and the students have wrote the exam fairly as well, okay, mostly this bell distribution will occur. Okay. Whereas, in a non-normally distributed data does not fit into a Gaussian distribution. So, coming to the common causes of non-parametric statistical test, that means non-parametric data. So, in reaction kinetics, some chemical reaction does not follow a normal distribution due to complex reaction mechanism. So, another example for non-parametric data is a equipment failure rate often follow an exponential or Weibull distributor rather than the normal distribution. Particle size distribution is another example for non-parametric data, that is not normal distribution. In polymer or catalyst manufacturing, particle sizes often follow a log normal distribution. So, we know already what is the difference between a log natural logarithm, log to the base 10. I am not getting into that part. So, the log means it has been increased 10 power, for example, 10 power x, 10 1, 10 power 2, 10 power 3 is a log normal distribution. So, what are the assumptions which is made in the parametric test? What is the assumption made in the non-parametric test? Requires normal distribution. So, no assumption about distribution in the non-parametric test. What is the data type? Continuous and normally distributed, whereas this one is a skewed data, that is a skewed, the size has been what you called skewed in the sense compact, I mean compacted, reduced. Okay. So, ordinal, rank or skew data, Example for parametric test is t-test, analysis of variance, regression, whereas in non-parametric test, Mann-Whitney U-test, Kruskal-Wallis test, okay, and efficiency more powerful when assumptions are made, okay, more robust for small and skewed data sets. So, we will go for non-parametric test when there is outliers of data, okay, or when a skewed data is there, then we will go for a non-parametric test. So, we should know what is the difference between the parametric test and non-parametric test, okay, based on the assumption of normal distribution in the parametric test, non-normal distribution is for non-parametric test. And coming to the parametric statistical test, what are the tests we will do? One is t-test and two sample t-test. So, used to compare the mean of two groups, then we will go for t-test. One sample t-test compare the sample mean to a known population mean. Example, in chemical engineering perspective, testing if the average reaction yield of a catalyst matches the expected 85% efficiency. Coming to the two sample t-test, compare the mean of two independent groups. Example, comparing the efficiency of two different heat exchanger design. Okay, entirely different, two different heat exchanger, then we want to compare, then we need to go for a two sample t-test. And a paired t-test. So, comparing the reaction yield before and after the process modification. Let us imagine you have a reactor. So, I just want to vary the reaction process modification. Okay. So, in that case, before and after, how much is the variation? Then we will go for a paired t-test. The formula has been given here, T is equal to x1 bar, okay, minus x2 bar, that is x bar is a mean, okay, point number 1 and point number 2 before and after, square root of variance divided by number of samples size, s1 square divided by n1 plus s2 square divided by n2, which is in the denominator under the square root. So, coming to the analysis of variance, there is a categorization, one way ANOVA and two way ANOVA. One way ANOVA is a one independent variable, whereas two way ANOVA is a two independent variable. Let us see an example. Okay. One way ANOVA compares means across one independent variable. The example is comparing three different catalysts to determine which one gives the highest yield. Okay. So, we are comparing the three different catalysts and determine which one is giving the higher yield. So, two ANOVA example is analyzing the effect of both temperature and pressure on the reaction yield. So, the variation we have impact of two independent variables on reaction yield. So, independent variables are both temperature and pressure. So, coming to the regression analysis, again in the previous class we have seen a linear regression method, linear regression, multiple regression. So, My is equal to Mx plus B, predicting the heat exchanger efficiency based on the flow rate. Let us say heat exchanger efficiency has been denoted by Y and the flow rate has been denoted by X. What is the variation? When the flow rate changes, what will happen to the heat exchanger efficiency? And coming to the multiple regression and predicting the reaction yield based on the temperature, pressure and catalyst concentration. So, reaction yield is based on three parameters. Okay. So, we will go for a multiple regression. And coming to the non-parametric statistical test, that is the data does not match, does not have any assumption, does not fit into a Gaussian distribution, that is a normal distribution. So, in that case we will go for this test, I mean for the skewed data or outliers we will go for this test. There are four tests has been mentioned here for non-parametric statistical test. One is Mann-Whitney U test and Wilcoxon signed rank test, and the third one is Kruskal-Wallis test, and the fourth one is Spearman's rank correlation test. Coming to the first test, non-parametric alternative to t-test. This is an alternative to t-test. So, the t-test is only for a parametric statistical test. This one is an alternative to what you call U-test. U-test is alternative to t-test. Comparing the viscosity of two polymer samples when data is not normally distributed, then we will go for a U-test rather than going for t-test. And coming to the paired t-test, non-parametric alternative to the paired t-test, okay, that is a Wilcoxon signed rank test used for dependent data, that is a paired data. comparing the impurity levels in wastewater before and after treatment process. Okay. And coming to the third test, that is Kruskal-Wallis test, which is the alternative to ANOVA. The example is comparing the 3 different solvent extraction for metal recovery. The fourth test is Spearman's rank correlation, which is a alternative to Pearson correlation. Example is examining the correlation between the catalyst surface area and the reaction rate when the data is skewed. So, the correlation between the catalyst surface area and the reaction rate. As the surface area increases, the reaction rate increases, as we know. Okay. So, what is the correlation of this? Okay. This is the maybe when data is skewed. Okay. It is not normal distributed. For certain cases, we could not able to come under the correlation very effectively. Okay. Because we might have seen actually different empirical correlation formulas. Okay. So, we know aware of it. Okay. So, when you have this type of thing, when we will go for a Spearman rank correlation, where non-parametric statistical test. It is a non-parametric statistical test. Coming to the confidence intervals. Okay. A confidence interval provides a range within a population parameter is expected to lie. So, the confidence interval has been given as Ci is equal to x bar plus or minus z multiplied by sigma standard deviation divided by square root of n. So, z is critical value from the standard normal table. So, the fifth method, which is coming under the non-parametric statistical test, before I told actually is a 4-way. Okay. So, we have another one is called a confidence interval. I can give an example here. 95% confidence interval for the average reaction time of a chemical process is 4.5 minutes and 5.2 minutes. So, this means that there is a 95% probability that the true average reaction time falls within this range. So, the reaction time falls within the range will be 95% confidence. Okay. Only 5% may deviate. Okay. So, that is the meaning of it. Okay. Hope you understood this. And application of this chemical engineering, the parametric, both parametric and non-parametric. The first two example for parametric statistical test. Okay. And what you call the second two one is the equipment reliability and environmental analysis, a non-parametric method. Okay. Let us see one by one. Process optimization using ANOVA. So, ANOVA is coming under a parametric statistical test. Okay. And t-test is again a parametric, whereas non-parametric using survival analysis to estimate the failure time of pumps, which is coming under the non-parametric method. Environmental analysis like using non-parametric test to compare the population level in different wastewater samples. And coming to the conclusion of today's lecture, parametric tests are powerful when assumptions hold, but non-parametric tests provide flexibility for non-normal data. Both are crucial in chemical engineering for analyzing the process efficiency, ensuring quality control and making data driven decision. So, what for we are doing all this? Okay. So, in a nutshell, I would like to explain, we have an enormous amount of data we need to collect, we are collecting it and we are we are correcting it some infant noise level, I mean removing the data. Okay. And then we just relate, we see the testing, okay, how it has been distributed, normal distribution, things like that. So, that we could able to come to the conclusion, okay, analyze with the data, analyzing in terms of for the process efficiency or ensuring the quality control and making the data driven decisions. Only for that we are doing all this aspect. Okay. So, when you try to have this data, enormous amount of data, okay, then we will give to the machine, okay, it will able to give a decision proactively. That is what is necessity of studying this subject, especially the data analytics and machine learning for chemical engineers. So, it will definitely will reduce the amount of time as well as in terms of cost estimation, okay, in terms of energy consumption and then the process efficiency, quality control and also we have a robust system, okay, in under control, under us regarding the conversion of raw material, while converting the raw material into product. Okay. So, this is the objective, I mean this is the overall view of the content why we are studying so far. Okay. So, we will see in next class Hopefully we will got it actually today's lecture. Most probably we will see this third subdivision of unit 3 in the coming section. Thank you.